Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from summer 2023. This paper is worth 120 marks in total, and this is the 6th video of 6. It will focus on questions 21 to 23, which account for 19 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. 21a, solve 7x subtract 5 equals 2x add 3. So we've got an equation where we've got the unknown on both sides. So the first thing I'm going to do is I'm going to eliminate the smallest of those unknowns. So I have 7x and 2x. 2x is the smallest, so that's the one that I'm going to eliminate from both sides. So at the moment it's positive 2x because there's no sign in front of it. The opposite of positive 2x would be negative 2x. So I'm going to subtract 2x from both sides. When I subtract 2x from the right hand side, 7x subtract 2x is 5x, and then I've still got the subtract 5 there. When I subtract 2x from the right hand side, that eliminates the 2x and just leaves me with that positive 3. Now, because I'm solving, I'm aiming to get it in terms of x equals. So the next thing I'm going to eliminate is the negative 5. So instead of subtracting 5, I'm going to add 5 because we work with inverse operations. When I add 5 to the left-hand side, that eliminates the negative 5 and leaves me with 5x. And then when I add 5 to the right-hand side, that goes from 3 to 8 because 3 plus 5 is 8. The last step is going to be to divide by 5 because currently it's 5 times x, and the opposite of multiplying is to divide. And when I divide by 5 on the right hand side, I have 8 over 5. You can leave it as a fraction if you want to, or you can convert it to a decimal if you know what that decimal is. You also have a calculator, so you could put the fraction in and get the calculator to tell you what it is. Either of those answers is going to get you full marks. Part B. Rosa is buying bananas and apples. She buys X bananas that cost 30 pence each. She buys 2 more apples than the number of bananas. Apples cost 25 pence each. She pays £5.45 in total. Use an algebraic method to find the number of bananas Rosa buys. Okay, so she buys X bananas at 30 pence each. So the cost of her bananas in total would be 30x. She buys 2 more apples than the number of bananas she buys. So we could represent that as the number of bananas plus 2. And her apples cost 25 pence each. So the total cost for apples would be 25 times the x plus 2. So 25 times the number of apples. She pays £5.45 in total. So what we're going to do is if we add the total of bananas and the total of apples, it should cost £5.45. Now we're dealing with pence here, so I'm going to ignore that decimal point and deal with pence in terms of the pounds. So now we've formed an algebraic expression. 30x add 25 multiplied by this bracket is equal to 545. Remember, we're dealing with pence right now. So I'm going to expand that bracket. So 30x add 25x plus 50 equals 545. 30x plus 25x is 55x. And now we've got an equation to solve like the ones we were solving up here, look. So I'm going to subtract 50 because it's the inverse of adding 50. And then I'm going to divide by 55 because it's the inverse of multiplying by 55. So x equals 9. Okay. X is the number of bananas. So that's our answer. Part C, factorise x squared, add 5x, add 4. So this is a quadratic equation that's got a squared term and a number term. So we're going to need two brackets. Each brackets will have an x in because x multiplied by x gives us x squared. Now we need two numbers that multiply to give us 4 but add to give us 5. So we could have 1 times 4 or 2 times 2. 2 plus 2 is 4, so it can't be that pair. 1 plus 4 is 5, so it must be 1 and 4, and they're both positive. So we factorise that expression into two brackets. Question 22. So we've got a diagram of an aircraft descending towards a runway, and they formed a right angle triangle for us. The diagram's not drawn to scale, so we can't measure anything from the diagram. So an aircraft is making its final approach ready to land. The aircraft is flying at 3 degrees to the horizontal. So we've got those 3 degrees to the horizontal here. And it's 2.5 kilometres horizontally from the start of the runway. So we have 3 degrees from the horizontal here and 2.5 kilometres from the runway here. So that's the base of the triangle. And that's that angle on the outside that's made between the triangle and that horizontal. Calculate the vertical height of the aircraft above the horizontal ground. So the vertical height above the horizontal ground is this height. This is the horizontal ground, and that's the aircraft there. You must show all your working out. Okay, so we have a right angled triangle. We're trying to find a length. So it's either going to be Pythagoras or trigonometry. Now, if it's Pythagoras, we need to know two of the sides of that right angled triangle. We don't know anything about this side, so it's going to be trigonometry. Now, for trigonometry, to find a missing side, we need a side and an angle. So we need to find this angle or this one. Well, I'm going to find this angle because they've told us that the angle with the aircraft and the horizontal is 3 degrees. This is a right angle, so 90 subtract 3 tells us that this angle here is 87 degrees. So we have an 87 degree angle and a 2.5 kilometre length. So let's label our triangle. So this is the opposite, this is the hypotenuse, so the H must be the adjacent. So we're looking for the adjacent and we've got the opposite. So it's O and A. So if you remember SOHCAHTOA for trigonometry, we're dealing with the tan ratio. It's the only ratio that deals with the opposite and the adjacent. Opposite, adjacent. So tan of our angle, we've worked that out to be 87, is equal to our opposite over our adjacent. Let's fill in what else we know. The opposite is 2.5 and the adjacent is the height that we're looking for. So now we know we're looking for the adjacent. So if we cover this up, we're doing the opposite divided by tan 87. That's what this formula triangle helps us with. So we're doing H is equal to the opposite divided by tan of 87. And it's really important that you write it that way in your calculator. Ooh, and then close your bracket at the end. So the opposite side comes before the tan. And then when I press that, we get 0.13101944482. This is in kilometres. Okay, so you can say that it's 0.13 kilometres from the ground. Doesn't ask you to convert it to metres or anything like that, so this would be absolutely fine. It's 0.13 kilometres height from the horizontal ground. 23. Heath has £3,000 to invest for 5 years. No extra money will be paid in or withdrawn during these 5 years. He's going to choose which one of these accounts. So the option here is account A, 4% compound interest per year. Interest rates can vary. Account B, guaranteed interest at the end of 5 years of £190 for each £1,000 invested. Part A, which account gives Heath the greater percentage increase in his money at the end of 5 years and by how much is it greater, you show how you decide. So let's work out how much interest he's going to earn and what his account will look like at the end of 5 years with each of these two options. So account A, 4% compound interest per year. So if you're starting with £3,000, that 4% compound interest, we're going to use a multiplier of 1.04 because it's 4% increase, and that's a 1.04 as a multiplier for 5 years. 3,000 times 1.04 for 5 years. So that's 3,649.96 in pounds. I rounded it to 2 decimal places because it's money. Okay, account B. Guaranteed interest at the end of 5 years of £190 for every £1,000 invested. So 3,000 divided by 1,000 is 3. So you'll get 3 lots of 190 at the end of 5 years, which is £570 interest. Okay? So that would be 3,000 plus 570 at the end of the 5 years. So we want to see the greater percentage increase. So percentage increase, we're going to do the difference, which is the interest earned, divided by the original times by 100. So the difference, divided by the original. So this is a 21.67%, and then the difference here is the interest, %. So account A gives the greater percentage increase, and by how much is it greater? Well, 21.67 take away 19, it's greater by 2.67%. The assumption that we've made here is that the interest rates in account A don't vary, because it mentions that account A interest rates do not vary, because it says here they can vary. So if it did change within the 5 years, that would obviously change this value. Part B, comment on the effects that your assumption in part A has had on your decision. Okay, so the effect it's had on our decision is that as long as it stays the same, we're correct. So if it's consistent, we're correct, but it could be higher or lower depending on what happens.